I get enjoyment out of simple things, like possibly the saddest moment in my life is I was once a subscriber to Concrete Quarterly, which feels like it should be on Have I Got News For You? Welcome to Electrical Engineering here at the University of Cambridge. I'm Peter Christopher. I'm a postdoctoral research fellow here. This is part of the Cambridge University's grand plan to move all of the engineering provision out of the centre. We might as well take the lift up, I guess, save carrying it upstairs. This is the device that made our research group famous, and also it's one of Cambridge University's largest spin-outs. But this is a holographic projector in here as opposed to a classic on-focus projector. So one of the features of a holographic projector is it's got infinite depth of focus.
Thank you very much, Peter. Thank you for being here.
Thank you for having me.
I think we had a great trip in your lab, and that was exciting.
It's always nice to show people around.
So today we will be talking about two things. Moon exploration and holograms.
Yes.
Just to mention one thing, that the two things don't come together, because you might be aware of that conspiracy that the moon is a hologram.
It isn't.
It isn't.
I wear two hats. I work at University of Cambridge, which is the holograms bit, and I'm also chief scientist for a company called Exobotics that does satellites and moon exploration.
Okay, so moon exploration started with the Russians, who managed to land the first probe on the moon. That was in 1959, I think, and then that was when there was a space war. Then Kennedy gave a famous speech. He said, "We do things because they are complicated," but it was also doing things because of the space race. And so they eventually managed to send a probe on the moon in 1969, I believe. And the program lasted for like 3 years, I think. So at the beginning of the 70s, they stopped sending people on the moon.
Yeah, so I think 69 was when they landed Neil Armstrong.
Yeah. Do you think it's real?
Yes.
Yeah, me too, yeah. Okay. What do you think there are all these conspiracies around?
Well, as someone trying to do what they did without computers or calculators, really, 50 years ago, and I'm trying to do it on significantly better kit, and I realise how hard it is. I can understand why people think it's made up.
Yeah.
It's not easy. I think it feels unrealistic. I don't know. I'm not an expert on conspiracy theories, but I think that people like to have an understanding of things that are beyond their ken.
So now there are there are programs going on. The Chinese managed to send a probe to the dark side of the moon for the first time in history with the Chang, what's the name of it? Chang 4. That was in early 2019. And now we're expecting the Artemis program, which probably is planning to send a human to the moon, right? It's a NASA program.
I'd have to check. Sorry, I'm not the space expert. I do the software and.
Yeah. But what do you think? What do you think is the reason now? What do you think we should go to the moon right now in 2022 or 2020?
Because we can. It's the obvious answer, but I think it's also a testing platform. So the difference about us going back this time is we're not going back, because to prove the point, because we can do that. But in real terms, today's money. Yeah, the NASA programs that sent Neil Armstrong to the moon cost $1 trillion or something.
$1 trillion?
I think if you scale for inflation, I'd have to check the exact numbers, but it's a lot. And that's obviously very expensive. And the big difference is that over the years, we've moved towards commercial space. It used to be satellites were just made by governments with government level funding. And nowadays you can buy a satellite. It will be expensive. It will cost you millions, but it's not going to cost you billions unless you want something huge. But there's an entire ecosystem, commercial sector built around this. If you're a telecoms company, you can buy a telecom satellite. And the idea is that could we go to the moon for that? Now, the difficulty is there's not necessarily as obvious commercial advantages of the moon. Telecoms is an important reason why you'd want to be in orbit around the Earth. And I think, if I'm honest, there's an element of exploration. There's an element of people doing it because they can, like the Elon Musks of this world. And then there's an element of people applying for the very high risk, high reward of, could we ever mine asteroids? So there are things you can do on the moon that you can't do on Earth. Like, there's manufacturing techniques. It's non-tectonic. So even though it's not necessarily obvious to you and I, there are vibrations.
You have moonquakes. Very little tiny moonquakes, I think. Well, compared to the Earth.
Yeah, compared to the core of And that's a major issue if you want to go down from your 5 nanometer lithography process or something. One of the major issues is the vibration. Also, you can get a higher vacuum on the moon than you can on Earth. But I think the thing people are really playing for is the slice of the $1 trillion pie that would be asteroid mining. The rare materials we use inside all the devices around us are rare. Extremely rare, and they're very hard to get, and some supplies are running out. So moving towards being able to mine an asteroid would be a fantastic situation. Now, obviously, that's 50 to 100 years in the offing.
And the problem with these rare earth materials is that I think they're kind of they're not really abundant in the West. They tend to be
so there's
elsewhere.
There's also a geopolitical element. So many of them are just rare, full stop, and some of them are only abundant in certain countries.
And there is exploitation involved and all these things. And,
So I mean, you get the same issues with, say, batteries in electric cars. It's, there's ethical sourcing requirements on when you buy your T-shirt. But there's also ethical sourcing requirements on when you buy your materials. But whereas in theory you can make a T-shirt anywhere, just you need to pay your workers enough. You can't mine materials anywhere.
And now, if we think in terms of moon exploration, moon mining, what do you think we can extract from the moon? What's in there that might be useful for either missions there or bringing it back to the Earth?
So that, I guess there's 3 elements here. First is, this is my area of expertise. So the second is that there's the materials that will be useful here on Earth and bringing back, for which I don't think there's a lot the moon has. So the moon's main element now would be as a staging base for future exploration. But there's things that we could be mining on the moon that would be useful for building a moon village or moon system. For example, I was in a presentation about 6 months ago by a guy talking about building reactors for taking lunar regolith to extract oxygen from it, where you ended up with an interesting situation where metals were the byproduct, which obviously, like most things on Earth, like metal is the thing you're after.
So you can build stuff with the regolith. Regolith is the moon dust, basically.
And that's one of NASA's big programs, is the idea of building this moon village.
Okay.
And the big issue is the moon does make a good starting point. It's a solid base on which to build. Because gravity is 1/6 as powerful as on Earth. It's very easy to get on and off of it. So you could very well imagine a scenario where we captured resources from an asteroid. We then did manufacturing on the moon, and then we shipped things down well to Earth.
Okay. So you're talking in terms of electronics manufacturing there.
I mean, that's the obvious one, yeah.
Okay.
But basically, very high value to weight ratio.
But one thing I'm not really familiar with, I think we discussed this thing back in July when we had the first chat, and I was saying, I don't think, when you think in terms of, let's say, I'm familiar with the scanning probe microscopy, which is basically you have a probe and then you look at matter at the atomic level. So you can get, for example, scans of gold lattice with atomic resolution. You can see the atoms of gold. You can even see the atoms of silicon. And one of the things they do is that, of course, they do it in vacuum. But they also use a system of springs or even magnetic levitation to damp the vibrations. And then they can even put the thing in an anechoic chamber, which is a soundproof chamber. So do you think it's worth, I mean, if we have all these kind of procedures that we can do here, do you think it's worth doing that on the moon? Is it still relevant or...
Yes, I think it's about
Yeah.
it's about costs.
Okay.
And I think it's somewhat of an open question. I'm not, again, to be clear, this is not. I'm the engineer here. I'm not the big picture economist. But my understanding is that there's a potential it could be very valuable. The issue is about basic cost to weight. So we could put some numbers on this. If you want to put something into low Earth orbit, rough rule of thumb, it's about £100,000 a kilo. Obviously, it's significantly cheaper if you do it in bulk.
Okay.
If you want to put something into orbit around the moon, it's roughly £1 million a kilo. Again, this is to order of magnitude only.
Okay.
You may be able to get it much cheaper. You may cost you much more depending on scenario. You want to land it on the moon, you have to double it again. And if you want to drive around on the moon on a rover, you have to double it again.
Whoa.
So it's it can be very, very expensive.
So maybe you need to manufacture electronics for usage in the moon itself. Maybe you're going to have a base and you need to have that electronics instead of waiting for a cargo to be shipped from the Earth. And
So one of the questions I've been asked a couple of times, I've been a panelist, is always like, so when are we going to send humans back to the moon? And my argument would be, I'd actually like to have our company tagline as Exobotics beyond human, because I don't see any point in humans. And obviously not in general, but in terms of space exploration, it's cool to have a human in space.
Okay.
But the reality is I don't think in the near future there's ever going to be an economic demand for humans in space. There's nothing that you can do that we can't do with a robot, bigger, faster, better, cheaper, lighter, you name it.
But then you can always find someone that wants to go there for the experience. Or there are things that robots cannot do, and having a human there is always good. Plus, there is the excitement aspect that people would like to.
Yeah, so there's massive economic advantages for society having humans, and it's cool. It captures the mind, and that's fantastic. And it would be a good thing to do. I guess I'm thinking from the engineering point of view in terms of doing something, like.
Yeah. I know, yeah.
A human is a 60 to 100 kilogram organic vehicle that excretes material and requires vast quantities of material. Yeah, that's a lot of stuff that needs to be looked after. And it happens to be a lot of stuff to look after that we understand. We know what humans eat. And there's always going to be unknowns on the moon and things that we may not have the robot prepared for. And I think we're a long way from, I guess the quote Star Trek, fabricated technology. Yeah, if we go to the moon with a robot and we suddenly discover we need a slightly different robot, we aren't going to be able to make it on demand. But we're not too far from that. 3D printing is only a first step, but you could imagine in 50 years that we'd be able to design, simulate, VR everything on Earth.
Okay.
But again, this is obviously very concept, as all space stuff is. Yeah, and the engineer in me always wants to sort of solve the real world problems in front of us now. And that's where people wanting to go to space is a big part of it. There's a lot of the motivators for commercial space is either underwritten by the taxpayer, particularly the US taxpayer, or there's people with lots of money who want to do cool things.
Yeah. And I think another, before I forgot to mention that, another thing that can be extracted from the moon is helium-3.
Yes.
And that, because that's rare in our planet, and that might be a fuel for future fusion reactors.
Yes. So, helium-3 is one. There are a couple of other things as well. But I think the primary motivator of the moon is that it's the nearest body, is a stepping stone for places beyond. And the big one would be...
Like Mars, for example.
Yeah, the big one would be that... So the issue with... The reason why SpaceX can carry a much larger payload than, say, the Apollo missions could, is that once you've burnt all the fuel to get into orbit, the amount of space you've got left for payload is very, very light. So even very minor weight savings in your rocket or efficiency savings can make massive difference in your payload. The issue is there isn't a lot of efficiency to be made, if you like. Like a car engine, you can actually burn fuel a lot more efficiently now than you could 50 years ago. That's why you do 50 plus miles to the gallon as opposed to 10. Whereas in space stuff, you're burning the same fuel as we burnt before. It's not like we discovered a revolutionary new fuel. And you're just shooting out the back of your rocket. So maybe you can make you can be a little bit more efficient in that. There's massive savings to be made in the weight of your rocket. and in the efficiency of your payload. But the breaker would be if we could send the payload to the moon, and then we could refuel or build a new rocket and then go from the moon beyond.
Or build extra stuff that we might need for Mars and build it on. So can you explain why is it convenient to ship stuff from the moon instead of from the Earth?
Because so the big term people use in the space sector is what's called delta V, and the idea is if you want the heavier objects, you warp space-time to give you your gravity well, and the amount of delta V you need to get out of Earth is a lot. It's obviously not as much as the sun, but it's a lot. Whereas the moon, because its gravity is about 1/6 of Earth, means you have to use a lot less energy to get out of its gravity well, and resulting you've got a lot of weight left. And there's some quite unintended consequences of this. So I'm relatively new to the space sector. I joined when I helped start Exobotics, my two co-founders. So there's a lot of things that took me by surprise. One of the ones was that actually it's easier to go to Mars than it is to go to Mercury in many ways.
Well, Mercury is too hot. Right.
Not even about the planet, just purely in terms of the orbital mechanics.
Okay.
Going to Mars gives you have to burn fuel to get there, more than you would say if you wanted to go to the moon. Mercury is down well of Earth, so actually your issue is you have far too much speed you can't get rid of. So while the fact Mercury is closer and you would, on paper, easier to get to, it's actually much harder to get to because you're moving way too fast. You can't lose that velocity. And that was one thing that actually in hindsight makes perfect sense, but I certainly didn't expect it when I came into the industry. But yeah, that's why there's been more rovers on Mars than there are on Mercury.
I don't know, what's the temperature of Mercury? Let me check.
Don't know offhand.
It's going to be bloody hot.
I think it is pretty hot. Oh yes, so it's minus
400 degrees.
Yeah, it's just daytime temperatures.
I think Venus is even hotter than Mercury. That's because of the atmosphere. Yeah, no, it's about 460. Yeah, it's hotter than Mercury. And that's because of the atmosphere. I don't think there is such a dense atmosphere on Mercury. But one thing I wanted to ask you is about the... so using the moon as a platform for exploration in other places in our solar system, could be Mars, could even be the moons of Saturn or Jupiter, whatever. How do we get the fuel?
I believe you can make it. But again, this is definitely not my area, but I believe you can make fuel from the regular. But yes, feel free to fact check me on that.
There is, I think the Artemis is going to land on one of the poles of the moon, right, where there is a high concentration of water. If you do electrolysis with the water, you can get oxygen and hydrogen. But I don't know what's the fuel for normal rockets. I think there is oxygen, right?
Again, I'm really sorry, I don't know. This is I'm still playing catch up.
Okay. Well, I think there is probably there is methane or something.
I don't know. Sorry.
Liquid methane, I don't know. Another thing I wanted to ask is that one of the things they say is that dark side of the moon would be a great space for great area for doing astronomical observations.
It would be, yes. It's also cold. Very cold.
Yeah. 40 Kelvin or something, yeah.
Yeah, so Exobotics has looked a couple of times at doing stuff in so there's two things here. Dark side of the moon isn't dark.
Okay.
And now that's another thing that surprised me. So the dark side of the moon is the bit that's facing away from Earth.
Yeah.
But it has the same exposure to the sun as our side. So a day on the moon is 14 Earth days, and then there's a 14-day long night to give you your 28-day moon cycle. But the dark side of the moon, like if you look at a crescent moon, the dark side of the moon can also be the bit that's facing the Earth, and vice versa. So dark side of the moon refers to the bit that's away from Earth.
So opposite to the Earth, yeah.
So the key thing about the Chinese rover wasn't landing on the far side of the moon. Or at least from the engineering point of view, the key thing was it could operate during lunar night, which is incredibly cold. And that's one of the biggest issues about lunar exploration. It's not that it's cold, because cold we can handle. there's no sunlight, so there's no power input, so you have to run on batteries.
That's right, yeah.
Or or basically tiny little nuclear radiation things that keep the thing warm. And that's part of the issue, is because it's a big rover, square cube law means that it loses less heat per unit of volume as a smaller craft. So that's one of the things we've really had to work on for Exobotics.
Okay. Now, I'm curious one thing. Now, let's talk about technical challenges on the moon.
Yeah.
Certainly, the dust is a big problem. The dust, I mean, if you're sending humans, that dust apparently is toxic.
Yes.
You might get silicosis, which is what workers get when they work in very dust environments. But then there is also another problem, that it's electrostatically charged.
Yes.
It gets everywhere. Now, is this how do they fix the issue with the rovers? Because the thing can go anywhere, it can go in between things, and
you try not to kick it up is ironically the biggest thing you do. You also try and elevate your craft a lot. It's one of the reasons why lunar. So there's basically two big reasons why lunar rovers are so far off the surface, as far as the big ones. One is that rocks on the moon are awkward. They're not like in the pictures of all these giant rocks with then basically smooth sand around it in terms of and that's how it's always done in artists' impressions. But actually, the reality is that rocks on the moon don't really allow you to drive around them. You typically have to be able to drive over them. Okay. There's quite a wide variety in sizes. Although obviously previous missions have tried to go to places that were smooth as possible. And the other one is dust. So you want to keep your delicate instruments away from the...
So you need to go slowly so that you don't bring it up.
So you go slowly. You also have wheels that try not to disturb it. So they won't have like a standard tyre grip. They'll have like vanes that slot in and out, so they smoothly go in and out while still providing good grip. And then there's... Yeah, those are the two big things. Also, you'll try and keep all the electronics self-contained.
Yeah, because it's electrostatically charged.
Right. Yes, but it's not. Yeah, the electronics of the situation isn't so much the problem. Obviously, you could
shield it. Yeah,
it's more just dust getting where it shouldn't be.
Yeah.
So you wrap everything up. I mean, I would say the biggest issues that we've been facing. Obviously, there are lots. There's temperature, there's mass, there's radiation, and then there's magnetic field. So the biggest one is temperature. If you're operating in space, then you've either got constant exposure to the sun, or you've got only short periods of eclipse. And your exposed cross section to the sun is as consistent all the time, and that's pretty nice because we can build a craft that operates at, you name a temperature between -70 and +100 or so. We can build a craft that operates at roughly that temperature.
Celsius degrees.
Yeah, sorry. And we can change the albedo of the craft, the amount of heat it rejects. So as long as we've got constant heat input, we've got a lot of design choices to be able to work for that. The issue is when you've got variable heat input. Say you go into eclipse and you go, you're hidden behind another solar body. Or you have something like a lunar rover, which isn't a sphere, and over the course of a lunar day, the sides of it that are exposed to the sun changes the cross-sectional area and also the amount of heat it can reject. So thermal's the big one. Mass is another very big one because it's very expensive to get things there. So rough rule of thumb, and again it's only a rule of thumb, but the cost for things in low Earth orbit is primarily dominated by volume. So you can afford things to be heavy. Now if you send something made of lead up, people are going to complain, but it's primarily volume. So for the moon, we've had to look at entirely new ways of making things that are lighter, stronger, and things. There'll be a whole bunch of composite materials and new architectures for deployment that are not needed for low Earth orbit. Radiation's another one. We're on low Earth orbit. The two key things are A, you're primarily protected by the Van Allen belt, so there's a lot less of a radiation issue. B.
So can you explain what's the Van Allen belt?
Oh, it's this. It's effectively a shield around the. We'll see. We'll get a picture maybe. But it's effectively a shield around the Earth, which captures a lot of the radiation.
And that's due to the magnetic properties of the Earth.
Yeah, so we capture radiation, and it almost forms a blanket around the outside of the Earth. That's my understanding. Again, not my area. And
this radiation is basically causes problems towards electronics.
High energy particle comes from your solar system, like cosmic background radiation, or something, and a classic example is may flip a bit in your computer, and if that bit is in the which direction do I want to be firing my thrusters command, then that causes problems. So my biggest role within Exobotics is on the software side. So how do you write software that doesn't crash?
So redundancies and all these things.
Yeah. And sometimes it's as simple as, okay, you run the program 3 times and you get it to vote. But what if the voting procedures gets broken?
Okay.
So it's answering questions like that. And there are a bunch of tricks and things you can use, and it's more of an issue on the moon because A, the radiation is more abundant. B, its makeup favours radiation. It's very difficult to shield for. Also, shielding is heavy because shielding is basic. You basically can't have light radiation shielding.
So shielding, you would do it with the metal and Faraday cages and things like that, or thick materials like lead or something.
So in terms of materials, straightforward to use. Aluminium has the best weight to shielding ratio.
Aluminium.
Yeah. So for volume, lead's best, but obviously lead's really heavy, whereas aluminium's quite light.
Can you use electromagnetic fields like magnets or something? Similarly to what happens with the Earth, with the Van Allen.
So yes, Faraday cage will pick up some things, but that's not typically the major issue. It's the high energy particles that Faraday cage is not going to stop. That's the problem.
So using a magnet wouldn't work?
Not really.
It would be too heavy, probably.
Also, whoever's taking your mission up to space is going to complain if there's a giant magnet in there.
That's right. Yeah. And it's going to be very heavy, very, very heavy.
Yeah. So.
Or require a lot of power.
So it's a major issue, or at least it could be a major issue. As technology's moved on, it always used to be people trying to avoid ever having bit flips and ever having problems. And as technology has moved on, people have gone towards a model of being able to handle the problems when they arise. And I personally much prefer that model. It keeps me in a job. But also, I think it's a much more sustainable model in future.
How do you detect a bit flip?
You typically don't. I mean, you can, for example, when you communicate over the internet and you send someone a message, you would normally send them with a checksum as well. So, for example, if I send you a message saying, "Hi Samuel," I could also get a hash of that, some mathematical function of the message I'm sending, and send the checksum, and then you at the other end can do the same piece of maths, and if there's an error, you'll know. And then there's more advanced code systems where you can error correct. A bit like you have like a RAID hard drive or system.
Yes.
It's you can.
I was thinking about this.
Oh yeah, you have written.
I wrote RAID 5.
Yeah. Basically, it's that. There's the message equivalent. And there's memory equivalent. There's computer operating system equivalent.
Can you use a blockchain system for that?
Yes.
Because if you're sending the wrong thing, it's not going to be accepted, right? Because there is a check that needs to be performed.
Yes.
For the following block, which could be a message.
So there's a lot of people who are very interested in using blockchain or crypto in space-esque stuff.
Okay.
There's several reasons for that. One, it's cool. Another one is that the openness of the ledger makes life a lot easier security-wise.
Would you be able to explain how this thing works? Because I find hard time to explaining it to people.
Do you want the 1 minute or the 2 minute answer?
Whatever you want. Go ahead.
Okay, so the 10-second introduction, the 1 minute introduction to internet security is that one of the biggest inventions of all time in the internet security world is the idea of a one-way function, or a one-way lock. And the idea is that you can encrypt something using one code, but you use a different code to decrypt it. The idea is a public-private key. So the idea is that I publish my public key on a website. Now, if you want to send me a message, you can use that public key to encrypt it. But you couldn't then unencrypt the message again. If you like, it's like a padlock, which if I give you an open padlock, you can close it, but you can't then open it again. And then I give you, you send me a suitcase and you padlock it with my padlock, and only I can unlock it. And then a lot of security problems boil down to, okay, so let's say you want to send me a message for the first time, how would you do it? And for example, if you could take your suitcase, you could put your padlock on it, and then send me the suitcase, and I could padlock it with my padlock. Then I could send it back to you, and you could take your padlock off, and then send it to me, and I could unpadlock it. And at no point in the middle could someone unlock it.
Yeah.
So that's the 101 on internet security. And blockchain is not a not dissimilar approach of public-private key relationships and on a ledger system. But yeah, I'm not yes, I'd probably have to go and do some prep to find a good way of explaining it that doesn't become too convoluted.
So how did you become interested in space exploration? When did it start?
So I'm going to be blunt. My interest isn't in space and exploration. My interest is... No. Genuinely isn't. I don't...
In building rovers?
It's not even that.
Okay.
There's two other engineers in the company, Nadim Gabani and Maxime Begons.
Okay.
And they're amazing. And I love my interest is the engineering challenges. And space has a lot of them, and they're really interesting. But if I found those same problems somewhere else, I'm just as interested in doing something else.
So it's the approach that matters.
Yeah, it's what problems do you get to solve today, and it's one thing I've always tried to do for jobs and work is to find something that is going to be fun to solve. It may not be easy, it may not be lucrative, but it'll be fun.
But if you tell people I work in the space industry and we are doing all this,
I mean that is true. Yes,
different.
It does. It's certainly good for starting conversation in the bar.
Yeah.
But yeah, so the Exobotics started in 2018, and Nadim Gabani asked Maxime and I whether we wanted to join, and we said yes. We've been for a few iterations since then because our first contract fell through because one of the launch provider went bankrupt. So we had to reinvent ourselves building COTS, and now we're back, I guess, where we were before. So we've got 4 missions lined up for this year. So that means we got customers have paid for 4 things. I'm very limited on what I can say. I had to get my crib notes handed to me by Nadim, but one of them will be going into a lunar orbit.
Nice. And
it's on a CubeSat. So that will be quite a big thing for us. We'll get to test a lot of our kit in a lunar orbit, which has never been done before. If that works, which obviously we're doing our best to make sure it will, that'll be a fantastic, be a major breakthrough for us and also for the community as a whole.
Yeah. And so you started collaborating with a company called PT Scientist, which is a big German company.
Yes.
But they are back in business as soon as
yes.
As far as I
understood.
They
are. Yeah. They got bailed out by the German government, and they're now known as PTS. But by the time that had all gone through,
it's a big company, a big space company, right?
They're a decent size. And we went out there, I think, in early 2019 for a PDR. It was just after...
For a what?
So preliminary design review. So you would typically take the basic idea, but the key requirements to preliminary design review.
And that was for the rover?
Yes.
Okay.
And then you then go back and come back for CDR, which is like the technical review.
Okay.
And that's when it's approved and you can start going building it.
Okay. And so what's this rover like? Can you describe it? Like how heavy is it? I understood it's like
show a picture on the
size.
website if you want.
Okay. Or shall I open the pictures that you sent me? Or?
Yeah, that's on there as well. Yes,
This one is.
Well, to scroll down, I think there should be a picture of the actual rover. Yeah, there we go.
This one, yeah?
Yeah, 1011.
Okay. So this one is the size of a CubeSat. What's a CubeSat?
So CubeSats were an idea, I believe, concocted by some students at an American university. I forget which one, in the 90s. And the idea was to basically modularize space in a similar way to, say, with a computer now. You have an ATX system and you can buy a case and a motherboard and a GPU all separately, and there's standards to make sure they all work together. And it's a good idea because up until that point, satellites were very, very large, very, very heavy. And also, they weren't very standardized. And having a standard system has meant, space was a lot more accessible for a lot of people. So that's the popularity of CubeSats. I forget the exact numbers, but a vast percentage of all satellite missions are now based on CubeSats. Again, it means you can have a standard deployer, basically standard everything. And in theory, if you had the money and you were willing to wait for the lead times, you could buy everything you'd need for a CubeSat right now. It wouldn't take you more than a few hours worth of quote gathering to buy all the bits. We could screw it all together in a couple of days, and then we could send it off to fly. Now, obviously, we'd need to test it and meet lots of criteria, and the design bit's not that straightforward, but it's not as easy as building your own computer, but it's not that far from it. And
so this one, what kind of system does it? What kind of sensors does it have?
So this is a platform. So this has cameras and the things we'd need to drive around. And if you go on to the next slide, you'll see that the legs fold out like this. So this is a CAD model. Obviously, that's not the real thing. And the idea is that it comes with about half a U of payload space. So we refer to CubeSats as 10 by 10 by 10 centimeter cubes. So that's a 2U version, and of that, 1/4, so half a U, so 5 centimeters tall by 10 by 10, is up for the customer. And whether that would be some kind of VR system.
So those are solar cells?
Yes.
And I've seen that you also manufacture solar cells and you sell them separately as well.
So our aim is eventually to control the full stack.
So you sell different parts?
Yeah. Okay. Currently, if you buy one of our systems, it'll be about 50-50 stuff we've built ourselves.
Okay.
And stuff you can buy from other customers. You can buy from other companies.
Yeah.
And our aim is eventually to sell the whole thing. And I think one of probably the future of satellites, certainly small satellites in my opinion, is going to be something called a software-defined satellite. Because the actual hardware that goes into a satellite is not that expensive. The manufacture cost isn't expensive. It's very expensive to buy because they're very low volume, and it's very expensive to buy because there's a lot of tests involved. And I'm very keen for us to move to the point where you can buy almost the entire satellite on a board. There's a minimum of connectors, a minimum of things to go wrong. Yeah, and then the software is what defines it.
So the hard part is what actually goes in the system, basically.
Well, in terms of failures of satellites, things go wrong in space. Sometimes for reasons we know, sometimes for reasons we don't. For example, and there's lots of unexpected things. One of the classic examples being a phenomenon known as cold welding, whereas you have two metals when a very very clean, very very crisp edge in a good vacuum, they will often weld themselves. And then deployable things, like say deployable panels or something, can have problems. Now we've learned to deal with that. We have dissimilar materials and stuff, but the unexpected can happen. Also, sending a satellite up in a rocket is pretty it's pretty high intensity. It's not exactly gentle.
Vibrations and stuff, yeah.
And the inside of a CubeSat may have 20 different PCBs all wired together. Any one of those connections could go wrong. And ideally, I'd like to move to having satellite on a chip where everything, except for batteries and solar panels, is in a tiny little box.
All in the same chip?
Yeah. that is the dream, but we're away from that yet. But Exobotics' big vision is that we want to make the whole systems. So if you want to be a customer, you come to us and you say you want to fly this mission. We'd build your satellite. Optionally, we'd integrate it for you. Optionally, we'd operate it for you once it was launched.
Mm.
And our aim, in a couple of years' time, is that we'd also build all the kit. Because lead times in the space industry are very high. Like, we've currently got one part that we're expecting to take 32 weeks to be delivered. But supposedly, commercially available off the shelf.
Mm. So I understood that the plan is to, if you want to do some exploration, is to send a swarm of these kind of little robots that can cooperate and work together to achieve a certain target.
Yes.
Is that the kind of idea?
So actually communications on the moon are actually quite tough.
Okay.
The reason for this is that comms on Earth are easy because radio bounces off the atmosphere. That's not true on the moon. If you lose line of sight, it's actually very hard to talk to something. And now in 10, 20 years' time, there's probably going to be very reliable ways of getting around this.
Can't you just have satellites orbiting?
Yes, but you've actually got to do that, and the number of satellites you've got to have for coverage is it's not one.
And line of sight wouldn't work because the curvature of the moon is it's different from the one in the Earth. I don't know what's the line of sight that you can get on the moon. Maybe I don't know.
Well, it's
a few kilometers. Maybe I don't know.
It depends on the terrain. There's lots
of course. Yeah.
I mean, we'd like it to be able to go down inside a crater on the moon or a lava tube or something. So a big part of the swarm theory is that it allows robots to work together to keep, effectively a chain of communication while covering a reasonable amount of ground.
And maybe one breaks and the other one can take over and so on. And
I feel
redundancy as well.
Yeah, so that particular one there, minus payload, weighs only just over a kilo.
One of those is one.
Yeah, so it's about the size of a loaf of bread, and it weighs 1.1 kilos. More or less.
Much bigger. That's small. Okay.
Yeah, it's pretty small.
And what can you mount on it? What do you what sort of equipment do you think can be mounted on it? Like,
I don't think you probably wouldn't want anything too disturbing. I don't think this particular one you wouldn't want to drill on it. I'm sure we could build you one for a drill or something. So this one would probably be primarily mapping and exploration.
Okay.
So there's little holes in the side there where we mount our cameras, but we could also mount a much more complex set of cameras and LiDAR.
Like maybe something for analyzing the terrain, spectroscopy, or ground penetrating radar to see what's underneath.
Possibly not the radar because of power requirements, but the others definitely, yeah.
So it's basically exploration and seeing what's there, the terrain, and
yes, I think in the short term. But I think we want to eventually to do it all, as a company. But baby step. The issue is the market. There's a really strong market for orbital stuff. There will be a market for moon exploration. It's just in its infancy, and we're very keen to be first movers, but nothing in the space sector moves fast. So we're having to do a twin strategy where we build stuff for commercial space in orbit and also prepare stuff for lunar space.
I was wondering, I was mentioning that before, what kind of solar panels are you using there? What kind of materials are you using? I think I've seen that it's over 30% efficiency on your website, maybe 36 or something. Okay.
No, I saw 31. But if you go on our website, you can see the technical details.
Another thing I've seen that you guys do is you have system that can be used to test stuff that you're going to send to space. You got a vacuum chamber and you also got some vibration stage. What's this vacuum chamber for?
So the other two co-founders on the company have a space background, and I think they got frustrated with the way the space sector worked, which is that the idea of flight heritage is incredibly important. I.e., if you're trying to sell a flight computer or something, people want to see that it's actually flown before successfully.
And so you need to fly the flight computer on an actual airplane.
No, in space.
In space.
For people to want to buy it.
Yeah.
And that's my concern is that doesn't make sense in today's manufacturing world. Where you shouldn't have to try something to have a good idea whether it's going to work.
If you have a good model.
Yeah, basically. And we should be able to test to space standards as much as possible on Earth. So everyone will do thermal vacuum system testing, but it will be in something the size of this room, and it'll be very, very expensive.
Like the ones that we see at NASA, where they have these massive chambers where they test things. I think that I remember that I saw when they tested that drone that they sent to Mars. They were testing it in one of those chambers, I think.
So that's really nice. It's really cool, but it's very, very expensive, which means for small satellites, people will just do that at the final stages of the testing process. And that's not how the rest of the engineering world is moving towards. Nowadays, you can go to your 3D printer and print something to try something out. So our idea is to basically build a vacuum test system. So this one does vacuum and temperature, but later ones will also include like solar simulation and stuff.
So radiation as well.
Radiation's more tricky because the big issue of radiation testing is you then need to block it from going everywhere else.
No, but you can use the sort of solar simulators that we use for solar cell testing. It would be a lamp that is.
So that's what radiation is fine. Yes.
You have that.
Not in this model. It will be in a later model.
And that provides heat as well. Right. Not that.
So heat's heat. Yeah.
Not that the sort of heat you. I don't know what kind of temperatures can you get with that system, with the system that you have.
I mean, high temperatures are easy because it's just resistive heating. Low temperatures, we use a heat pipe system to get it out, and I think we'll get down to minus 50, minus 80. But again, it depends on the model. Because it's very much dependent on the amount of back end basically. So the cheap ones are relatively high, lowest temperatures and that. But the aim is eventually that you'd be able to sit down between your espresso machine and your 3D printer and your laser cutter. You'd also have one of these and a vibe test kit. Because it makes much more sense to be able to do it that. And you combine it with a digital twin, you do all your modelling in a program like, in our case, Fusion 360. You then run all the simulation in your app. You can then go to your printer and you print the test parts and then you see whether it works. And that rapid iteration is much better for design and manufacture.
Can you simulate the electronics or just the mechanical parts with the Fusion?
So with Fusion you can do it both, but it depends again on what you're trying to do. Like Fusion is certainly aiming to be an all-in-one package, but it's not made by us. So we definitely go outside. For the optics, for example, we'll use Optics Studio by ZMax and things. We use a wide range of tools, but Fusion is typically the starting point because it's definitely been designed with A, usability, and B, breadth in mind.
So this is a 3D CAD software that you use to design all the parts, and then you assign materials like this is a metal, this is a plastic piece, and so on. I remember that with the Inventor that we discussed before in the lab, it was possible to simulate heat transfer and simulate if things might reach a point where they break.
So Fusion does a lot of that. There are some tests and the more advanced tests that you have to do somewhere else. So we
software-wise or actual practical?
Software-wise.
Okay.
Like obviously thermal models are very complex beasts, and depending on the setup, it can make very big differences to what you do. But in terms of I guess the scoping out test, Fusion does everything, and most of the advanced tests Fusion does. And there's a couple of things we take it outside for. Like Fusion doesn't have an optics plugin, which is something we need quite a lot of for, say, cameras.
Could you use COMSOL multiphysics?
We have done. We have a license. Most of our stuff works well with ray tracing, so we've been using ZMax quite heavily.
Okay.
But I think.
So basically what you do is that you have some project in mind, you design it with the software, with this AutoCAD software or Autodesk software or ZMax, whatever. and you get some conclusions, some results, and then eventually you need to test that on the actual testing platform for real, right? That's something you need to validate all these things.
Yeah, I think the dream, and this is a long-term dream, is that you should be able to understand and emulate the space environment well enough that you wouldn't need to go there to test it. Now, obviously, flight heritage is going to be really important for a long time to come, but it shouldn't be something holding us back, which it is in many cases, because a product will have flight heritage, therefore you'll buy that one instead of maybe the newer, better one, which doesn't have that flight heritage yet. We'd like to have a system where we can have flight heritage, but also there's a history to design.
Yeah.
If you buy, for example, if you go to buy a boat or something, it will probably not be the same as the previous boat built by the boat builders, but it'll have a lot of history, and the builders will be part of the trust relationship.
Yeah. An example would be the semiconductor industry. You design a semiconductor processor, a chip. We're gonna do everything via software. You know that you need to test it in a computer, and then because the fact of the manufacturing itself is a very expensive process, so you need to get it right. And then when it gets into manufacturing, it's not just to make one. If just to make one, it's very expensive, so you need to make lots of them. But that's a mature technology, and they have very good models. So I think
that's basically what we're keen for in Exobotics, is that the space sector has been around a long time, but has been chronically underinvested in by governments, and now there's a growing commercial interest in it. There's a need for bringing, the more advanced manufacturing approaches and design approaches that we've developed for every other industry over the last 50 years into the space sector. And some companies are doing a fantastic job of this already, and this is where Exobotics, that's one of the things we want to do as well. We want to change the world, but I'd rather change the world from my bedroom than by having to spend 5 years waiting for something to fly and discover I made a mistake.
Another thing I wanted to ask, in terms of power, other than solar cells, does it make sense to use nuclear batteries or
not on something that size?
No.
So this,
does it only work for tiny chips, or it also works for big things?
There's a lot of licensing issues. Obviously, the US government.
Well, I would imagine.
The US government isn't that keen on people sending radioactive things to space on their rockets, or on SpaceX's rockets for that matter. Yes, I don't. Power is cheap in space, ironically enough, particularly on the moon. If you want to go into deep space, it's different, but on the moon, it's not that difficult to send lots of solar panels. Solar panels are really light, and it doesn't matter if they look ugly, and you can deploy them. So it's not like there's infinite power and you can boil a kettle on demand, but there is quite a lot of power available for small craft. Now, the square cube law means as you scale up, if your craft is now a meter cubed rather than 10 centimeters cubed, your surface area has gone up by 100, but your mass has gone up by, your surface area has gone up by 10. Yeah, it's gone up by, I'll try one more time. If your craft is a meter cubed instead of 10 centimeters cubed, then your surface area has gone up by 100 instead of, but your mass has gone up by 1,000, and therefore your power demand has probably also gone up by roughly 1,000.
Yeah. What are those holes over there?
That's the wheel stoves.
Where you store the.
So the key thing is this particular one is designed to fit inside a standard CubeSat deployer, which you can basically think of as a square Pringles tube. So the silver rods on each side, on the four corners of the craft, are rails, and that's what slots out of the tube. So it has to fit inside a deployer in a folded configuration. So one of the things that's unique about this design is the other lunar rovers are being made and designed for the commercial missions coming up for the next few years. They're all deployed via a ramp, and they're all basically look like small cars. And that's a good design, but you then have to design the lander around it to be configured. Whereas this will fit in a standard CubeSat deployment system.
How do you land this thing? So what kind of I guess you have a simulation software for these things, right?
Yes.
Okay. What can you do with this thing? Can you move objects in space and then test and try different things? And
So primarily, yes. I feel, possibly varying towards what I can't really say here.
but that's something you made, right?
Primarily, yeah. So
Okay.
it's jury rigged on top of commercial.
So like a video game or something like that.
Yes, a very, very ugly video game. I'm an engineer, yeah. Form over function. Sorry, function over form. But yeah. So the key thing to note is that this is a product you can buy, but it's what it does on the moon is very much defined by the users. We're consider ourselves a bus. We're the last mile system, but the customer decides what you want to do with it.
But there must be common components the navigation system must be common. Yeah. What do you have, a LiDAR or something like that?
Can neither confirm nor deny. Okay. Depends on configuration.
Well, you can navigate just with the cameras if you want. If you look at the most recent DJI drones, they do a very good job with just camera navigation.
Yes. The issue is obviously getting enough processing power for onboard software to do that navigation, or the delay in any kind of comms link.
Okay.
But I just want to be clear that this is not something we've yet sold one on. Also, we want to, and it's something we're working towards. You could buy one of those offers, but we wouldn't be able to ship it to you tomorrow. Whereas, like many of the bus systems that we are actively working on our website, we could send you tomorrow, and it will be well.
Do you mean the testing systems and the panels and so on?
Yes, but we could also send you a satellite. So the 4 missions we're working on at the moment, they're all due to launch before the end of this year.
That means coordinating the satellite thing, all the
paperwork. So for example, one of these missions will be going to a lunar orbit. It's going to fly a payload from a customer. Will fly around the moon. And we're just providing the satellite for that.
Nice.
And that will go into a lunar orbit. And now the operation will be done by a separate company. So we just provide the satellite and the hardware and the onboard software. The customer puts their payload in, but like a CD tray into a computer case or something. And then we ship it to the integrators who put it in the rocket, and then it gets launched. So we're building the satellite but not operating it.
What's the most difficult thing that you find when designing software for these projects?
Trying to reverse engineer what other engineers have done on their bits with badly written manuals. You know how it is. Like the actual software itself is not too bad. It's trying to work out what someone else did on a previous piece of software or previous piece of hardware.
Trying to understand code written by other people as well.
It's code written by other people, but also because you're operating with lots of different components, all of which work together in slightly different ways, and be absolutely confident that it's going to work every single time means you've got to have a really good feel for how something works and all the edge cases on where it could go wrong. And that's what takes some serious effort.
Okay. All right, so let's change the topic a little bit. Do you want more coffee?
Oh, no, I'm good. I've got plenty.
I want to ask you about your entrepreneurship experience. When did you start? What was the driving force? And because I've read that you were a co-founder of something like 10 startups. You worked with big Fortune 500 companies and all these things. So what's the story?
So I've been on the founding team of 10 startups.
Okay.
Many in the software side of things. In my consultancy business, I've worked with a lot of big companies over the years. My first startup was a security applications thing. You mentioned blockchain earlier. It's not too dissimilar. I was, my original undergraduate degree was in civil engineering. I basically got bored. During the summer after my second year, I went and spent a weekend writing an idea I had. which eventually sold for enough. Unfortunately, much of the consultancy I've done and also the companies I've done have been very much on the security side of things, so I'm very limited in what I can say. That's why, so it's possibly not the easiest place to have an interview.
Security, like as what? Like financial security, things like that.
Can we turn the mics off?
Okay, don't tell me it's alright. Okay.
Yeah.
If it's military stuff, don't tell me anything. I don't want to hear that.
Yeah. So the stuff I'm working on now, I can talk about.
Yeah.
So the big one is Exobotics. We're doing reasonably well. We're cash positive and got a few big projects on the go. We feel like we're going places. I'm also consultant for a couple of other companies, and then I've got 2 other startups now, Prospectral and Nanomation. They're both very young.
Prospectral, you started in November 2021.
Yes. So Prospectral is very, very young. And we've got a novel filtering technique for multispectral, hyperspectral imaging.
Okay, so hyperspectral. I used the hyperspectral camera once. You can basically get multiple images at different frequencies. They use it for agriculture and all these things.
Yeah, so like an RGB camera has effectively 3 wavelengths it detects, but those wavelengths are quite broad, like anywhere in 100 nanometer range. Hyperspectral captures a lot more accuracy on that color information. Multispectral does that, but it only does it for some parts of the spectrum.
Okay.
Prospectral's got a better filter system than is commercially available, but the big advantage is what we're using it for. For example, an example at the moment is we're very interested in geology and mining, but an exploration there, and will also be agriculture and recycling, which is, can you tell materials apart? And this is a relatively common thing using hyperspectral. The problem is the systems are large and bulky, whereas what we want to do is build something that's basically a GoPro. So you've got a GoPro in the corner there, and basically we want to do one of those, but it's going to be hyperspectral. And the ideas of this are, some industries have got massive use for this straight off the bat, like say mining. But some industries are going to be it's going to take a bit more market building.
There's archaeology as well.
There's definitely archaeology.
Yeah.
The one we're really excited by is actually recycling. So there's some stat, and I forget the exact numbers on this, but like you send plastic to recycling, it's only quite a small percentage of that plastic gets recycled. And there's a whole bunch of different types of plastic that look the same to you and I. They're all transparent.
So you want to do inspection when it arrives after they collect it, you're going to inspect it when
Some recycling facilities already do that.
Okay.
Recycling facility, or at least modern ones do. I want to put it in your phone. I want you to be able to take your phone and point it at your dinner and see what it is, or point it at your bottle and see what the material is, and get some kind of eventually some kind of, I guess, score on how ethical it is, but also like, is this HDPE or is this what a different type of plastic?
There are already things written in the plastic.
So there are labels on plastic,
but
they're obviously not as easy as pointing your phone at it, and most people probably don't know what the labels mean.
Okay.
But that's again a long-term vision.
But then the way they dispose it and they recycle it, I mean, it's out of your control. I mean, you don't really know what's going to happen afterwards, so it's a system problem, I think.
I'm just trying to give examples of what we want to do. It's like, there were plenty of digital cameras before GoPro. The reason everyone has a GoPro is that anyone can take a GoPro out of the box.
Yeah.
Stunning pictures.
It just works. And it works, yeah.
And that's what I want to do for hyperspectral. Now, we'll see. It may not work, but that's our aim.
What would be the kind of frequency band that you can
It's going to be very much dependent on the...
Visible is from what? 380 to 700, I don't know.
Yeah. The rough rule of thumb is it's 400 to 750.
400 to 750.
But the UI has some sensitivity.
Yeah. In fact, I remove the filters for certain DSLR cameras and to take nice pictures. And
And so sensors and standard cameras are sensitive over a wider range if you take the filters off.
In the infrared.
Yeah. Now, there's two types of filters, I guess, that you're going to get on a digital camera. The key ones are, so if it's a color camera, it'll have a Bayer filter built directly into the camera sensor, so straight on top of the pixels. Our filter technology is somewhat independent of the sensor used. So in theory, we could build it on top of a long-wave infrared sensor just as well. We've never done that yet.
How many channels can you get?
Somewhat arbitrary, but double digits is the obvious place to go.
Double digits, okay.
I mean, we could do thousands, but you'd lose resolution. If you imagine I don't know, if you take a 4K camera, there's actually 4 times as much. And let's say you've got a 1 million pixel camera on your computer, image on your computer, then the camera to take that would be 4 million pixels. Because there'd be red, green, blue, and then normally a second green channel. Which is obviously quite a lot. So our system is basically, we'd pick the colours you want. Let's say it's red, green, blue, and I don't know, say you've got a special purple channel. That would be then 4 you'd need, so we'd be fine. But if you could have 16 colours, you could have 1,000 colours, but you'd only have very few sampling points on any one of them.
Okay. So, but do you design the sensors yourself, or you just put new types of filters, or?
No, the sensors are off the shelf.
You buy the sensors.
And again, I'm the software guy, and I guess to some degree the business development guy here.
Yeah.
I think the best piece of advice I ever heard from a friend of mine who's a far better entrepreneur than I'll ever be, and also far cleverer than I am. And her line was, you always want to be the worst player in the band. And I think she got it from a management book. But she's absolutely right. Is that, you're not going to learn anything if you're the person who knows the most in a team. So I always try to put myself in teams where I'm going to learn things from the people around me. Basically, I want to get carried. And obviously I'm going to do my best and I want to learn things, and I've learned a lot in everything I've done. But yeah. How
do you manage your time? You got so many things going on. You're working at the University of Cambridge. You're a fellow, right?
Yeah.
So you got all these companies.
Yes, I try to delegate as much as possible and control. The nice thing about software is you can get a lot of value for time expended, because there's a very large component of it goes on experience. And I've got quite a bit of software experience, which works out well. But yeah, I also don't sleep much, and I work very long hours. Last time I was in an interview for a job, a couple of times ago now, I was asked that's the classic interview question of what's your biggest weakness. I think the line is, for me at least, is that my biggest weakness spoils my biggest strength, is I get bored easily. And that's driven me to try lots of new things, but it's also meant that I haven't stayed still and carried on doing something possibly when I could have done more. And I've always struggled to stick at projects long term, and well, that's just me.
So when you write code, do you get help from other people, or you do everything yourself?
At the moment, everything myself.
Because getting someone that can write code like you is a bit hard.
I think.
Right.
Yeah, I'd like to position myself in the architect role. For example, Exobotics is currently hiring for software engineers. If anyone you know wants a job, and I feel the most value I can add is in that architect role of understanding the big picture. But to be blunt, I think it's much harder to make the hardware for something than to program it, typically.
You think?
Well, there's exceptions to every rule. But certainly in the satellite business, it's much easier for me to program the hardware than it is for Nadim and Maxime to build it. I definitely have the easiest job of the three of us.
Now, you have experience with the hardware construction as well, right? I mean, with this project that you have at Cambridge, you've been working with the holography since, I guess, from your PhD thesis, I guess, isn't it?
So I know I've spent a reasonable amount of time in the hardware world. Like when you came around, I was showing you a vacuum chamber I was designing. So yeah, my PhD project was on computer-generated holography. So it's not very easy to explain, but broadly speaking, if you've got a camera and an apple, then there's a one-to-one correspondence between the part of the apple that's being shown and the camera. So if you if you looked at the top of the apple, all the light that's being scattered off that top of the apple gets captured by a lens and then directed to one point on the camera. And if you look at the bottom of the apple, that's all captured by the same lens and then redirected to a different part of the camera. And holography basically adds a dynamic lens to your system. And there's a couple of advantages and disadvantages of this. The big advantage from my PhD project point of view is that you can make a lens effect give you a projected image. So you can shine a laser at what we call an SLM, so a spatial light modulator. But you can think of that as basically like a little TV screen. And if you delay parts of the light beam, you get interference patterns. And if you delay the right bits in the right way, you can get very complex interference pattern that looks like images. And you can have like a full projector built on a system like that.
Is it like the one you showed me?
If you imagine take a cinema projector or something, and you look inside that and you take one of them apart, you'll have a little LCD screen or digital micromirror device or something else that the light reflects off of, and then you turn bits of it on or off effectively to get a reflection. So you then show that through a lens, and that's shown on the cinema screen in front of you. And if you can see on this slide that what you're showing on your display is not too dissimilar from what you're seeing. Basically, the holograms allow you to do a few things. So for my PhD, my interest was primarily on additive manufacture and 3D printing. So there's roughly 3 types of 3D printing. Obviously, sweeping generalization alert. But there's extrusion-based printing. So that's the ones which you can get very cheap from home 3D printers. The most common example is a plastic that's melted with a heated nozzle. But I always like to think of it as it's squeezing toothpaste out of a tube.
Yeah.
And then there's the second one is stereolithography systems. The most common of which is basically an LCD screen or TV screen underneath a tank of resin.
So you have liquid, and then you move around this laser, and then the thing grows.
Well, so for the stereolithography ones, you can move a laser, but typically you just have a TV screen.
Then
the bits that are switched on cure the resin. So you're doing a whole layer at once. So again, there are laser scanning ones, but so the third type is the powder-based ones, which typically are laser scanning. When you move a very small heat spot over, say, a bed of plastic or metal powder very, very fast. Now, obviously, that takes longer, but the big issue is it also means you've got a tiny little melt pool. It's incredibly hot. Any kind of issues, like the powder being slightly wrong consistency or you just not predicting it correctly, causes massive issues.
So with the first two, you can make plastics, and with the third one, you can make metal printed parts.
Yes, so for the third one is the one you need if you're going to put enough power into melt metal. And my PhD project was on, could we use holograms to melt powders and basically to melt a whole area at once?
Instead of sweeping
the
laser.
So I did the first half of this, as a PhD always overruns, which is I basically built a holographic stereolithography system.
Okay.
Which was fun. But the powder-based one is ongoing. But the aim is that, we'd be able to melt an entire layer of metal powder in one go. So this is in pieces, I'm afraid. But this is the holographic 3D printer I built for my PhD. That's like a thing I printed on it, for example.
Wait, so the parts that you showed me in the lab?
They're plastic. So they're made on the stereolithography systems. That's not the type 2. So it's a vat of resin. And instead of having an LCD screen under that I'm switching on and off to cure it, I'm showing a hologram on top to layer it up that way. One of the things that interests me a lot about 3D printing is printing mechanisms in place. And this one didn't work exceptionally well, but in theory, you can turn the bottom gear and the top gear will turn. And it's printed.
So this one was printed all in once?
Yeah. So stereolithography is a lot more forgiving of having poor supports.
So all those little tiny parts, the ones in red,
Yeah.
those are all made using your stereolithography system using holograms instead of the LCD screen.
And then the blue ones are made on a Prusa SL1 printer for comparison, which is a standard LCD screen stereolithography system.
How about the piston?
That was just an extrusion printer. That was just me playing around.
And that big one, the red one that was close on top of your.
Yes, that's another personal project I started working on for an orrery. It's not finished. I never have the time to get around to it.
And so, tell me about your PhD. Then you finished this part, and did you manage to? Has anyone managed to complete the part where you have the powder and the holograms and?
We're still working on it. The reason it's all in pieces is I've got a 200 watt CW laser in the corner and a very expensive Santec SLM in the corner as well. So now I'm just designing a new system to integrate them all. We actually were having interviews for my replacement last week. I only technically finished my PhD in September, so only a few months ago.
Last year?
Yeah.
Okay.
So I'm only just out of my PhD.
Oh. Congratulations.
So I'm yeah. Someone says Dr. Christopher, and I still look around for my dad.
Yeah.
But yeah, that's nowadays my pitch is more on in my opinion, one of the more exciting things about holograms. So holograms allow you to do true 3D, and that's their real magic. So holograms come with a very high computational overhead that you wouldn't need to do with a classical image. They have a few advantages, like infinite depth of focus thing I was showing you earlier. But the big one is you can do true 3D instead of like a VR headset where you've got stereoscopic vision.
Yeah.
I don't know if you were at school, but you probably at some point during at school, your teacher would have told you to put a hand over one eye or close one eye and look at the world around you and see how everything was flat now. You probably did it and you probably thought the teacher was wrong. Certainly, that's my story. And because the reality is that your brain can see 3D with just one eye. It's not as good because and the stereoscopic vision thing, which is having two eyes looking at the same thing from slightly different angles, is the dominant feature of 3D vision. But there's a lot of other cues as well. And so one thing holography can do is it can mimic all the cues rather than just the one. So if you look inside a VR headset, if something's in you've got display here and here.
Yeah.
Your eye is actually focused on that point just in front of your face, not in the distance. Even if I'm looking at a hologram of you, my eye is focused here, and that can be very confusing to the brain. That's one reason why lots of people feel sick using VR headsets. And it also means it's not real world accurate. You wouldn't want to say train for a sport or to do brain surgery or to fly a plane using a VR headset because you're actually teaching your brain bad.
Do you get the same bad effect if you use augmented reality? Is it the same thing?
So augmented reality is just a VR headset that's overlaid on the world around you.
Yeah.
In effect. It's not as bad because you have a reference. But it is still an issue. And a non-trivial one. And holograms allow you to fix this. And in theory, at least, you could... So the picture on the right there is a screenshot from Star Trek. And the idea being is that you could overlay the world around you with this virtual world with projectors. And maybe, the dream is at some point in the future, that's what we'd be able to do. We'd be able to have a grid of projectors all around the room, and they'd all show you slightly different sides of the same image, and you'd be able to walk around the room. We could have this interview, and wouldn't be here. You'd be somewhere else.
So in terms of, I wouldn't, because I think I've seen it somewhere, and I've seen some videos where they would create these holograms in a room, big holograms. How big are these projectors? Just to have a reference.
So it depends on the technology used. So a lot of things in the media that are called holograms are not really true holograms. They're just clever ways of overlaying a flat image. And they have a lot of value. Like, I forget, there was some...
How about the concert with Tupac at Coachella?
Oh.
Or Michael Jackson? Were those real holograms or they were
no
2D images?
They're 2D images. Again, with... the magic of good art is that you don't notice the difference.
Well, if you are too far away, you're not gonna notice, right?
Yeah.
Well,
Well, maybe,
not
but
sure. Unless there is a drone moving around and you don't see the parallax. Because the trick with holograms is that you can see the parallax effect.
yes. So, and also, I'm trying to think of it. There's a very old phenomenon known as Pepper's Ghost, which is effectively the same thing as is used for
Pepper's Ghost.
Yeah, so the idea was that if you wanted to show a ghost in an old school theatre, you'd put a big sheet of glass at the back of the theatre, which you couldn't see the glass. And then underneath the glass, you'd have your blanket and your ghost shape moving around. And then you'd get the reflection of that off the glass without actually the audience being able to see the glass. And that's known as Pepper's Ghost.
Okay.
So there's an awful lot of variation. So when people say holograms, what they typically mean is some image that appears like it's floating in space, which is a legitimate understanding. Like, so when Microsoft HoloLens has no holograms in it, it's just overlaying your glasses with an image. My interest in holograms is doing an actual 3D image that's independent of context. If you go to a 3D cinema, and you get up to go to the toilet halfway through, it will appear like all the actors in the cinema are following you around the room because it's your point of reference is important, which isn't true for a 3D hologram.
So, do you think we will reach a point in which these projectors could be portable? Things you could have, like you could place in your room and then play video games or
room size systems? Long way away. Headset systems? Already on the way.
See, you could also have that in a headset.
Yeah.
Okay.
There was one of Cambridge's biggest new startups is VividQ.
VividQ.
And they make the software for headsets. Facebook Reality Labs. There's a couple of I wouldn't want to bet too much on this, but I'd say within 5 to 10 years you'll be able to buy VR headsets that do this. Definitely within the next couple of years you'll be able to get headsets that include some of these technologies. Headsets have an advantage is that because a hologram shows you everything, it doesn't make any selection on what your view is or which bits are in focus. It takes a lot more information. And it scales very poorly. So the amount of projectors you need to fill a room would be a lot. Which is the big advantage of a headset, because you know exactly where someone's eyeballs are. You can show just the hologram for that.
Okay. So how would it work? So you have a headset that projects a hologram where?
In front of your vision. It'll be like using a VR headset. Just it will be holographic as opposed to a classical projector.
But then you said the problem would be resolution.
So resolution will suffer because holograms have to show a lot more information than a normal image. They can't make as many compromises. So, if you have a 4K holographic projector compared to a 4K 2D projector, the 2D projector will look better, but they're more accurate. So there are many scenarios where accuracy is much more important than visual quality. Like, say, you're trying to train to be a pilot or something.
Yeah. But if you're watching a 3D movie or something, or if you're...
I don't think you'll be watching movies on it in the short term. But in a few years, maybe. Like, as we scale up to 16K displays and then whatever's next, 64, I don't actually know what's next in the pipeline. That's when things will get interesting, because then
I'm not sure about the scaling of 16K, because to be honest with you, there are many videos about that. But if you are a bit far away from that TV, that's a 4K TV.
Yep.
You're not going to be able to notice the difference between a 1080p and the 4K screen.
Absolutely.
So,
whereas the hologram difference.
Because that's in front of you. Yeah.
So that's my point, is that I think we're going to run out of the need for more pixels on a flat display, but they'll make holograms better. And there's no theoretical upper limit, I guess, to the hologram one. Obviously, the amount of computer power available.
Okay. So what's your next project at the University of Cambridge? What are you working on?
So I'm working on this 3D one. I've just got the money in to buy a LiDAR drone system.
A LiDAR drone system?
Yeah, so I want to test one of these 3D projectors in a real system. Can I get a user to pilot them? I've got a big lithography project on the go with Hannah Joyce and Tim Wilkinson. And I've got a few other side projects. Enough to keep me busy.
Okay. Now, another thing, I came across some project that you worked on an archery software or something like that. Is that possible?
Archery software? I did write an applet about trebuchets, like catapults once upon a time, but...
Catapults.
Oh, like the big seed...
Yeah. Oh, so that wasn't archery, it was catapults. Okay.
Yes, but I don't think that's...
What, for reenactments?
No, my brothers-in-law and I built our own catapult.
For what?
So, I had a church hall. We went to Wickes and bought a load of wood. I took some of my dumbbells to use for weights, and we launched beanbags across the room.
Okay.
That was pretty good fun, actually. We got a pretty good, we'd launch this thing we'd launch a big beanbag, across a large church room. That was pretty impressive.
Okay.
It's good memories. So some time ago now.
Did you run into troubles for that?
No, we got away with it. I didn't break any windows. So.
Okay, Peter, thank you very much for your time. It has been a great pleasure.
Thank you so much for having me.
Learned a lot from this.
Always happy to talk about engineering.